Hello everyone. In this video, I'm going to show you how to run SDX on VFC and use this SDX to connect client networks on Chameleon at two different sites. So the network topology of this demo is shown in this figure. We have two VFC created on Chameleon at TAC and UC. There is an exogenous NICE with two stitch ports and the circuits linking the two VFC directly. So logically, there is a direct link between the two VFC. We also launch client nodes on Chameleon at two different sites and attach the client nodes to a network that is also attached to the VFC. This is the network topology. So on Chameleon, we have already launched VFC and created a VFC and launched client nodes that is in the network attached to the VFC. On TAC, there is a VFC called SC19YY, and there are three networks attached to the VFC: Net PhaseNet 1, Net Exogeny 1, and Net Exogeny 2. They have the VLAN tag 2085, 3506, and 3502. There are also two client nodes that is under the exogeny PhaseNet 1 with the IP address under the same subnet. These two nodes will be our client node. Two client node on TAC. On UC, there is similar setup. There are two client nodes under the same subnet 200.17 and 18. They are connected to the same network called Net PhaseNet 1 SC19 safe. The VFC at UC is called SC19 safe, and there are three networks: Net PhaseNet 1, Net Exogeny 1, and Net Exogeny 2. This Net PhaseNet 1 is used for the client nodes on Chameleon. It has the VLAN tag 3022. And these two exogenous switchable network has VLAN tag 32 line 8 and 32 line 6. There is also we also have an exogenous NICE that connects the two VFC. There is a stitch port at TAC with the VLAN tag 3506, and another stitch port at UC with the VLAN tag 3296, and there is a link between them. This connects the two VFC directly. Next, let's look at how we run the SDX on VFC. We are using the VFC branch of CCSafe. in VFC.md, there are guides and steps to run the VFC, run the SDX on VFC. First, we run the SDN controller for the VFC. We have already set the SDN controller address of these two VFCs to an exogenous node that we have created before. This is the IP address for the SDN controller. We first log on to the node, the SDN controller node. We pull the we have already pulled the Docker image on this SDN controller node. We run the SDN controller with Docker. Now the SDN controller has started. Since I previously I have already run some tests with the VFC, so there might be some flows, old flows from my previous test on the VFC. What we do now is to delete all the flows on the VFC. So as we can see in the SDN controller command, there is a OFCT REST application. So this application provides us API to directly modify the flows, including deleting all the flows. So we will make call to this application. The commands are in the commands are here. Those are the DPIDs of the two switches. What we saw before is the so this is this is the DPID of the two switches transformed into digits. Now we have deleted all the flows on the VFC, including some default flows that when the switch first connects to our application. So we need to restart our SDN controller. We restart our SDN controller. This will get the default flows back to the VFC. This step is necessary. Now we have started the SDN controller. Next, we need to save the topology of the VFC in a JSON file. So in the VFC, we have two routers, which is the OpenFlow enable switch. One at UC and one at TAC. They have those DPID that's different, and we can assign different names for them. And there is a link between the two VFC. We also gave it a random name, and it connects these two nodes. And there is also three networks on each of the VFC. That is net FaceNet 1, net exogenous 1, and net exogenous 2. Three networks on UC with different VLAN tags, and also three networks on TAC with different VLAN tags. that's the topology file. Note that those keywords cannot be changed. We use router for the VFC, link for the link between the VFC, and the stitch for the networks on the VFC. Next, we start the VFC server. There is an instance already running on the node on the computer, so let me kill that process. Before we run the server, let's have a look at the configuration file. We are not enabling safe authorization in this demo because the process is quite similar to our previous setup with SDX on exogeny. We assign an IP prefix to the VFC because there is an internal link for the VFC network, and when we use REST router application, we actually assign IP prefix to those internal interfaces. So we need to give it an IP prefix. We just need to select the IP prefix such that it doesn't conflict with our client networks. The Plexus is not in the slice, and the IP address of the Plexus server is this node, is our exogenous node, and the VFC server is listening on this address, and this is the topology file that we have looked at. So next we start the VFC server. It has started. The next step is creating the client networks. Since we have already created the client networks, we are skipping this step. In the next steps, we will stitch the client network to VFC and advertise the IP prefix of the client network and request for connection between the two client networks. The SDX running on VFC can connect client networks on Chameleon and on exogeny. In this video, I'm only connecting the two client networks on two different sides of Chameleon. So we are only running the second set of the commands. First, let's stitch the client network at attack to VFC. Before we run the command, let's have a look at the configuration file. We give it a lane, and we are not using safe. This is the IP address of this SDX server. Since in the video I ran those commands on the same computer, so use localhost. But if we are running on different machines for different person, then we set this server URL to the IP address, to the public IP address of the VFC server. That's a configuration file. In the stitching command, we specify the site, which is tag, the VLAN tag for the client network, 2085, and we choose the IP address of one of the client node as the gateway, and then we and this is the IP address we assigned for the interface on VFC. Now the stitching has completed. It's actually fast because we don't make any changes to the network. It's just propagating some information to the VFC server. So it's fast. Next, we stitch the client network at uChicago to the VFC. The commands are similar with different IP prefix and different VLAN tag and the sites. Now the stitching has completed. Next, the client network will advertise their IP prefix to the VFC. This is for tag and this is for UC. Now the IP prefix advertisement has been done. Next, we will have the two client networks request for connection between their IP prefix. Before we actually do that, let's log on to the client node and see if we can ping before we issue the commands. Let's log on to a node, any node on UC. We can see that this node has the IP address 192.168.218. Before we set up the, before we connect the two networks, first the client node can ping to the other client node under the same subnet. That is 200.17. It works, but it cannot ping to the client node on different site. This one on tag, it doesn't work. So now we issue connection request between the two networks. From the message, we can see that the routing is set up for between the two prefixes. Now let's ping the client node at different sites. It worked. And we ping another node with address 18. It also works. So that's how we run SDX on VFC and connect two client networks on two different sides of Chameleon, and it works. For running this with safe authorization, the steps, the fundamental steps are similar, and the steps for safe authorization is quite much similar to those that we do with running SDX on exogenous and exogenous client slices. So I'm not repeating those steps in this video. And also to note that before I do the demo, I have already set up the routing configurations in the Chameleon client network. That includes set up the routing with Koga on every node in Chameleon. The steps are the guides on how to set up the routing are in the deploy-ch.md. The node how to set up the routing in the client node is available here in this file. Also, besides routing, we also need to enable the IP forwarding in the gateway node, because the SDX would send the packet to that client subnet to this gateway node first, and then the gateway node will forward the packet to other client nodes if necessary. So that's all. Thank you.